Hi, everyone. I hope you're all doing fine. I'm Frank Newman. I'm an associate professor in pure mathematics at the School of Mathematics and Actual Science of the University of Leicester. I'm also the director of admissions and outreach. I just would like to tell a little bit about myself, how I ended up to become a mathematician, and why I think mathematics is a great subject to study after high school, which offers you a lot of possible careers. Now, I really like exploring new things. I like challenges and find new territory, and I like traveling a lot. And so mathematics was a natural subject because I can explore, for example, mental landscapes, like what you see behind me is a picture, is a graph of a dynamical system coming of complex functions, iterations. And if you look in them, you can see that they have fractal dimensions. So basically you can zoom in and it will look always the same. And this is just a little part of it. So fractals you might have heard about are really beautiful objects. And for that, you need a lot of mathematics to study their geometry. So I studied in Göttingen in Germany, as you probably could see and hear from my accent. And I did a PhD there in geometry and topology, and then spent some years outside Germany, abroad in different countries before I came to the UK as a professor. And I should say mathematics is a very international subject. So I have a lot of research collaborators all over the world, in India, in Brazil, Mexico, United States, Australia, Brazil, France, Italy, Germany, of course, and also in Africa. I do collaborations with mathematicians in Ghana, Senegal, South Africa, and as well in Tanzania. And this is also a bit of mentoring. So I talk to students there as well. I also give courses for high school students in Africa, and I really enjoy doing that because mathematics is really a fascinating subject, and you might not see it necessarily in school, but if you come to university, you will see how beautiful the subject is, how much you can do with it. And the nice thing about it is that mathematics opens you doors to many very interesting and also well-paid jobs. For example, in industry, you know, mathematics allows you to model many things which happen in nature. Yeah. For example, you want to model the financial markets, which is very important. You want to model pandemics, which is very actual in the moment. You have a lot of data and you want to understand these data by finding patterns in that. And finding patterns is exactly what mathematicians do. Like, for example, in this Mandelbrot set behind me, this dynamical system, yeah, you see very interesting patterns. It looks complicated, but if you analyze it mathematically, you will find there's a lot in there you can really understand with mathematical terms, and you can make conclusions. So I'll show you another picture here, similar one, which shows you what's called the Mandelbrot set. You might have seen that. So I go a bit to the side. Yeah, there you can see. And these are, yeah, if you, for example, Google Mandelbrot set and Julia sets, you find a lot of examples and pictures. And this is like a universe. It's a mental universe because these objects you see there in the background are given by equations, yeah, with complex numbers. And if you see the equation, you might not see what kind of beauty and symmetry and interesting structure it gives. Maybe you have seen in school parabolas or circles, and you can describe them like x squared plus y squared is equal to 1, or y squared is x, or something like this. Yeah, so you have these polynomial equations, and they describe some geometric structures, some geometric objects, beautiful geometric objects in 2 or higher dimensions. The nice thing is in mathematics, we can even think about higher dimensions. Yeah? We just add some more variables, and we can write down equations in higher dimensions. We cannot really draw them anymore because we can only draw basically in 2 dimensions, 3 dimensions, maybe in 4 dimensions, we project to 3 dimensions in some way. Yeah, but we can think, mathematicians can think in higher dimensions, and this makes us really powerful in that respect. So let me show you some other example of nice shapes I'm studying myself. So this is what's called an algebraic surface. Yeah, so maybe I go a bit to the side, you can see this. It has a lot of holes in there, and it's quite smooth and round, and this is given by an equation in 3-dimensional space. And you can see there are a lot of, yeah, even though this surface is very curved, as you can see, there are some straight lines on it. And in fact, you can put 27 straight lines on it. That's a very deep theorem proven in the 19th century by a British mathematician, Cayley. And so it's quite amazing. You have a curved surface, which is not flat at all, but you can put straight lines on it. And in fact, exactly 27 ones. So this is what we call a cubic surface, because it's given by an equation which has highest powers of the variables 3. Yeah. So I just give you some ideas about what I'm doing. So this is what is called algebraic geometry, where you study geometric shapes by algebraic equations. Now you might ask, what other jobs are there if I study mathematics? As I said, if you want to go into the financial markets industry, yeah, banking, financial markets, stock markets, they need mathematicians for mathematical modeling. Engineers need mathematicians for modeling. Yeah, for example, you have you want to define or construct how a new say engine of a plane works. You need equations for that, and you have to study them. And this is called fluid dynamics. So it really is important what kind of turbulence properties those engines have. So you really have to study mathematical equations. If you do physics, you want to understand our universe, yeah, how it was built, the Big Bang, the structure of our galaxy. All this is related to mathematics by using physical equations, for example, Einstein's equations of relativity theory. These are what we call partial differential equations. They can be described mathematically, and their solution spaces give me shapes like this, for example, but then in 4 dimensions, so you really can visualize them. Or if you do meteorology, weather forecasting is a very complicated dynamical systems, and you have a lot of parameter and data to understand. And data science anywhere, yeah? As I already mentioned, evolutions of pandemics, understanding of how pandemics develop. You have a lot of data, but you need to find patterns to understand and find a way of figuring out what will happen next. So you need mathematical theories for that. And if you do data science, you can find any job if you have mathematical background. Statistics is very important, you know? Again, related to data science, to health science, also to biological and medical sciences, of course. And other areas you might think about is, of course, computing. Yeah? Mathematics and computing and informatics, computer science are very intertwined. And in fact, computer science developed out of mathematics. When Alan Turing basically built the first computer, he was a pure mathematician, a logician, and he was interested in the foundation of mathematics. And out of this came this wonderful first computer in the 40s and of the last century. And you see, there are so many links and fascinating areas where mathematics applies, that if you do mathematics as a core subject, you will have a lot of options later to find a really fascinating, interesting job. You can do research in industry, for example, or you can go to university, do a master and a PhD and continue. Yeah. For example, in Leicester, we have several master programs in applications of mathematics to data science, artificial intelligence, computing, financial markets, and so on. So there's a lot of things you can do, or you can do pure mathematics like me. You think about structures. There's a lot of, how to say, influential from all sides, applied and pure mathematics. And so there's a lot of synergy here, which makes it really a fascinating subject. I should also say that if you ask me what are the challenges to do mathematics, I think you just have to have fun. You should like to explore things. You like to find new ways, go new dimensions, new directions. I think then math is a really great subject. And you will see that mathematics has many facets you haven't seen in school. You will learn in the first and second year in university, for example, and then in the third and fourth year, depending if you do a master or a bachelor, you will have a lot of projects also, which allows you to study and understand mathematical problems in more detail. So I think if you think about a good career after high school, study mathematics. Come to Leicester, for example. So we have a lot of open days and school days. So you're welcome to come and come along, and I'm happy to talk to you about some ideas, what there is. In the moment, for example, all of our lectures are, of course, online. Yeah, because of the pandemic, we are not able to be on campus in the moment. So, but we do a lot of things online, and you can imagine mathematics has the advantage that you can show things directly on the screen. Yeah? Normally I use blackboards if I give lectures. Now I use my laptop. Yeah? And in fact, I can also listen to many seminars in the world. So I have a lot of collaborators in many countries, as I mentioned already. And we organize seminars where we have speakers from all over the world. Mathematics is a very global community, and it is really very international. So this is another very nice thing which I liked when I studied mathematics. And I didn't realize at the beginning how international it is. The language of mathematics is international. Yeah, we have our own language in some sense, using all these symbols. Some of them you have seen, and the idea is to see what these symbols mean. In fact, the symbols are nothing. What is important is behind, namely the geometric structures, algebraic structures, analytic structures, and so on. And the beauty of mathematics, you can find many different shapes you can understand, and it is really fascinating to look into this zoological garden. Okay, so I wish you all the best, and I hope to see some of you maybe on the campus in Leicester, and we talk about more about mathematics. All the best. Bye-bye.